السلام عليكم. نتابع محاضرتنا اللي هي على الفيز of water and latent heat. أوكي، إذا بالنسبة للwater والvapor والice, so it is possible for all three phases to coexist in an equilibrium at single temperature and pressure. This is called triple points T. إذا this is the triple point T, where is the three phases solid, liquid, vapor, and go from sublimation to fusion to vaporization. So B B vapor تساوي B الووتر تساوي B للآيس. إذا البريشر بهاي الحالة where is the critical point T, which equal 6.11 millibar. This is the figure between the pressure and temperature, and the pressure, the unit in millibar. Also T V تساوي T للووتر وتساوي T للآيس، والتمبريتشر in this case تساوي 273.16 كلفن. إذا and T تساوي this is T here is 0 سلسيوس وبنحولها ل كلفن. إذا which equal 273.16 Kelvin. Okay, critical point in thermodynamic state in which liquid and gas phases can coexist in equilibrium at the highest possible temperature. Okay, then above this temperature, water cannot exist in the liquid phase. إذا كانت تعلم هاي مستحيل إنه نلاقي الووتر في حالة الليكويد. So TC تساوي 374 سلسيوس and BC تساوي 221 ملي بار. إذا this is C, the critical point C at 221 ألف millibar, and Tc here is the temperature which equal 300 تقريبا 374 Celsius. Other atmospheric gases like oxygen O2 Tc equal minus 119 Celsius, and N2 TC للنيتروجين ناقص 147 سلسيوس. Another diagram called Amagat-Andro diagram. This is the equilibrium phases change in B, the pressure, and the volume. So if we look to this figure, the vapor phase, here is the vapor, here is the liquid, and this is the solid, and here is solid and vapor in this region, and liquid and vapor in this region. So what's happened when we have goes from A to B? From A to B, and we have here is temperature 1, and here is T at 0 Celsius, and this is the TC, T critical 374 Celsius. So what happened when goes from A to B? In this case, the pressure vapor equal rho للفيبر في R للفيبر في T للفيبر في temperature للفيبر. And here is the volume. In this case, we have decrease in volume. You can see from A to B, it's decreased the volume. And also increase the pressure. We have increasing the pressure. And heat is removed. طيب, what's happened when go from B? We have here is the border. If we look the border of the vapor, and we will go to from B to B prime. Then, if we look to this curve, we have a small change in volume, and this is cause the condensation. And some liquid water begin to form. إذا هون في عندي liquid and vapor. إذا ببلش يتشكل عندي إيش liquid water الماء السائل. And also إنه no longer behaves like an ideal gas. إذا ما راح يتصرف مثل إيش ideal gas. إذا here is the liquid water. Okay, another case. What happened if we goes from B prime at this point BW prime? Now the condensation occurs due to decreases in volume. You can see we have decreasing in the volume. Here is at the x-axis there is the volume. So it decreases the volume. And now look at T1 here from vapor to T1. Now the temperature become constant and also the pressure become constant. So in this case, water vapor pressure is at equilibrium. And then we increase, okay, from this point to, so we can see that the liquid is increased. Okay, another case. We go from where? From B prime to the border C at this point. Now all vapor has condensed into liquid water. إذا جميع الvaporization أصبح متكاتف as a condensation راحت لإيش السائل liquid water. Now all it goes to the liquid water. Okay, another case, we go from the point C to point D. What's happened? Now, if you look, we have small change in volume. We have a small change in volume and increase the pressure. So liquid water is virtually incompressible. Okay. So then the range of volume for which equilibrium occurs decrease with increasing the temperature. Critical point. This is the critical point C. So we have here a maximum temperature at which condensation or vaporization can occur. Then at maximum temperature. Here TC. TC 374 Celsius. So the maximum temperature here, the condensation or vaporization occurs. Water vapor obeys the ideal gas law at higher temperature. Either we will go to higher temperature, then we can use the ideal gas law for water vapor. So TC تساوي 374 سلسيوس and BC تساوي 221 بار or 221 ألف ملي بار. Then what's about the latent heat during the phase diagram between the pressure and volume? Here is 270 Kelvin at temperature, and here higher temperature at 373 Kelvin. So homogeneous system and vapor only. Then we have here vapor only and behaves like ideal gas. Isobaric process, heat, DQ added or removed from the system. In this case, the temperature will be changed and also the volume it's changed. So we can see that 273 Kelvin it's changed. We have 373 Kelvin and also the volume at this point change to the point to the volume at this point. So dq تساوي in isobaric process this means the pressure is constant and dq تساوي mc at constant pressure Tt plus VdP like in VdP because isobaric process the pressure is constant and in that case the change in pressure will be zero and this term it's cancelled. So dq تساوي mcb dt and we substitute that for the pressure at volume at vapor sorry تساوي رو للفيبر في ار في تي في. Okay, here is the diagram between the temperature and heat atoms. When we add, then the change with temperature with heat added. Then when two phases coexist, the temperature remains the same even if a small amount of heat is added. And it's here at C. Look here is the temperature is constant at this point. And what's happens? Vaporization goes to steam at this point. Condensation from steam goes to this critical point C. So instead of raising temperature, the heat goes into change the phase of the material. Melting ice, for example, here is the ice goes to melting or freezing, and then vaporization, water, and from vaporization to steam. Also, we can go back. And here, what we have added about the heat. Okay, here latent heat for some material, and then latent again we define the latent heat L Q تساوي M في L where the unit is joule لكل kilogram L تساوي Q over M and Q in joule and M in kilogram and this is some material for the latent heat and also for fusion and for latent heat for vaporization. So the heat required to convert from one phase to another is called the latent heat اللي هي الحرارة الكامنة اللي هي من بتتحول من phase إلى phase. So the latent heat L is the heat that must be added to or removed from 1 kilogram of substance to convert it from one phase to another. So during the conversion process, the temperature of the system remains constant. The latent heat diffusion is the heat needed to go from solid to liquid. إذا ال latent heat of fusion اللي هي اللي هي latent heat of fusion اللي هي الحرارة اللي بنحتاجها حتى تتحول من solid لliquid for all these material. And the latent heat vaporization latent heat اللي بنحتاجها للvaporization from liquid to gas, from phase of liquid to phase of gas. And this is the definition. The latent heat, again, is the heat that must be added to or removed from 1 kilogram of substance to convert it from one phase to another. Okay. This is example which will cause more severe burns to your skin. 100 Celsius of water or 100 Celsius of steam. أحيانا إذا أنه اللي بيسبب لك حروق أكثر إنك تحط 100 Celsius of water ولا 100 Celsius of steam. Of course, the answer it will be steam, and we will explain this next slide. Another example: you put 1 kilogram of ice at 0 Celsius together 1 kilogram of water at 50 Celsius. What is the final temperature? And الأف تساوي 80 كالوري بير جرام and C للwater تساوي 1 calorie per kilogram Celsius. So for answer the first question, so the steam, why? Because although the water is ended hot, it realizes only 1 kilogram, 1 calorie per gram of heat as it cools. The steam, however, first has to undergoes to phase change into water, and that process relies 540 calorie per gram. So, which is very large amount of heat here, 1 calorie per gram. But for steam 500 راح يحرر لنا 540 calorie per gram, which is very large amount of heat. That immense release of heat is what makes steam burns so dangerous. وهي ممكن أكيد كلكم تعرضتوا لها أحيانا أثناء عملية الطبخ أو أكيد أو في حالة غليان الماء، وكمان لما يجي البخار على على السكن، على الجلد، كيف إنه الحروق بتكون عالية جدا. أو إذا تعمل في شاي مثلا ولا كذا تغلي في الماء وكنت مغطي البريك الكب للووتر، وفجأة شلت الكفر، فبكون عندنا بخار. هذا البخار بيحرق السكن. It's very dangerous. So be careful about this. And here is the second question. حكينا you put 1 kilogram of ice at 0 Celsius together with 1 kilogram of water at 50 Celsius. اوكي، يعني احيانا بتروح تجيب لما تثلج الدنيا بتروح تجيب ثلج بدك تسيحه وبتحاول انك تحطه في 50 سلسيوس. So what is the final temperature? الاف بعطيني اياها 80 كالوري بير جرام and C الووتر 1 كالوري بير جرام. So you how much heat is السؤال another، يعني بيحكي لنا how much heat is needed to melt the ice. Q بتساوي M في LF وتساوي حوالي 80,000 كالوري. How much heat can the water deliver by cooling from 50 Celsius to 0 Celsius? So Q تساوي C للوتر في M دلتا T، إذا 1 كالوري وتساوي 50,000 كالوري. Thus there is not enough uh, to melt the ice. Okay, إذا latent heat during this phase change pressure بالملي bar, and here is the volume, and we take dq in this distribution, and here the Tc, T1 and Tt. So heat dq added or removed from the system, then the temperature in this case is constant. Volume change, we have change from V1 to V2 or V2 to V1. So the heat is needed to form or result from the breaking of the molecule bond that hold water molecule together. Magnitude varies with temperature. However, the range of variation is very small for the range of pressure and temperature observed in this troposphere. So assume constants in practical L بتساوي ايش؟ دي كيو. إذا latent heat تساوي ايش؟ دي كيو، so وتساوي constant. إذا latent heat during the phase change. Now heat is absorbed dq. This means dq is greater than zero. Here is the liquid, or from solid fusion to the liquid, from liquid vaporization, condensation to the gas, and solid goes to gas by process of sublimation. And from solid to liquid, the process is a fusion. From liquid to gas, vaporization, condensation. Okay, heat is released لما إيش تتحرر الطاقة أو الحرارة، يعني إن دي كيو less than zero. فبالتالي from liquid to solid we have fusion. From vaporization to condensation, from gas to liquid, vaporization, condensation, and from gas to solid, sublimation. Okay, this is the end of this lecture, and thank you for your attention.